I'm going to show you how to do unit conversions using metric prefixes. The metric system is based on powers of 10, making conversions simpler than some other systems. Conversions with metric prefixes just move the decimal point. What you need to figure out is what direction and how far. Here are some common metric prefixes. I'm going to do 3 example problems, each getting progressively harder. First, convert 3.4 kilometers to meters. The first thing I need is an equality. And I am going to write 1 meter equals 10 to the minus third kilometers. Alternatively, you could write 10 to the third meters equals 1 kilometer. Regardless of which of these two you choose, you should get the exact same answer at the end. But I am going to choose this first one. I prefer having 1 of the base unit and 10 to some power of the other unit. So you know how anything divided by itself equals 1, or almost anything, not 0 and infinity, but for example, 5 divided by 5 equals 1, a million divided by a million equals 1, the number of beakers you've broken in chemistry lab divided by the number of beakers you've broken in chemistry lab equals 1. I'm going to write 2 fractions based on this equality. Both of them are going to be conceptually equal to 1, but 1 meter divided by 10 to the minus third kilometers, or flip it around, write it the other way, 10 to the minus third kilometers divided by 1 meter. Now, neither of these fractions are actually equal to 1, but conceptually, they kind of are. 1 meter is equal to 10 to the minus third kilometers. So this is essentially a number divided by itself. Yes, the number is different, but the unit is different too. So think of either of these fractions as being conceptually equal to 1. And why is this important? It's important because something times 1 equals itself. 5 times 1 equals 5. A million times 1 equals a million. The number of beakers you've broken in chemistry lab times 1 equals the number of beakers you've broken in chemistry lab. What this means is I could multiply by either of these fractions and change the number, but I'd be changing the unit too, such that the quantity doesn't change. I just end up changing the unit. So I'm going to set up 2 equations. One of them is going to be wrong, and we'll discuss why. The other one will be correct. So what I have done is I have taken our original quantity that we want to convert the units for, 3.4 kilometers, and in my first calculation, I multiplied it by this fraction. In my second, I multiplied it by this fraction. One of these is the equation that we need to convert the units. And you can figure out which one based on whether or not the units make sense. Let's just look at the units now and not bother doing the math yet. But this first one, kilometers times kilometers divided by meters, this gives us some really terrible units of kilometers squared divided by meters. We don't want that. This is not what we want to do. If you set up the equation the correct way, units are going to cancel out in a way that makes sense. So down here we have kilometers times meters divided by kilometers. Kilometers divided by kilometers, that's kind of like anything divided by itself equals 1. Those two cancel out. So kilometers divided by kilometers cancels out. We end up with units of just meters. So this is going to be the equation that we want. The equation that we want has units that make sense. So what we need to do is take 3.4 divided by 10 to the minus third. And my answer is 3,400 meters. Problem number 2, convert 7.2 centimeters to millimeters. The reason that this is a little bit more difficult than the last is because we are going to have 2 different unit conversions that we need to do. So I'm going to start with 2 equalities. First is 1 meter equals 10 to the second centimeters. You could also say 100 centimeters. And 1 meter equals 10 to the third, or 1,000 millimeters. So let's set up our equation. Starting with the value that we know, 7.2 centimeters. I am going to first convert from centimeters to meters, and then from meters to millimeters. So let's just do this on the fly. I want my units of centimeters to cancel out, so I need the equality that contains centimeters. And because I want them to cancel out, I need this 10 to the second centimeters in the denominator. And the 1 meter in the numerator. So at this point, centimeters divided by centimeters cancels out, and our units are meters. But I need a second unit conversion to convert from meters into millimeters. That would be using this equality. This time I want meters to cancel out, so meters is going in the denominator, and 10 to the third millimeters is in the numerator. So this gives us an answer of 72 millimeters. I'm going to write an equation with just the units to prove to you that they cancel out the way that I think they do. So here it is. Centimeters divided by centimeters cancels out. Meters divided by meters cancels out. We are left with units of millimeters. And problem 3 is convert 9,200,000 centimeters cubed to meters cubed. The reason that this is harder than the last one is because we have more complex units in centimeters cubed. So I only need one equality, and that is 1 meter equals 10 to the second, or 100 centimeters. However, because we are going from centimeters cubed to meters cubed, we are going to need to apply 3 conversion factors. So think of centimeters cubed as centimeters times centimeters times centimeters. I will need to apply the conversion factor 3 times to cancel each of the 3 out. So for my equation, 9,200,000 centimeters cubed. So centimeters times centimeters times centimeters. I want centimeters to cancel out, so when I write a fraction based on this equality, I am putting centimeters in the denominator. So 10 to the second centimeters is in the denominator, 1 meter is in the numerator. But let's think about what would happen with this equation set up as is. I only have 1 centimeter in the denominator, so that's only canceling out with 1 of these 3 centimeters. If this is all I do, the units I'm left with are centimeters squared times meters. That is not what we want. I need to apply this conversion factor 3 times. So here, second centimeters cancels out, and the third centimeters cancels out. And we would be left with units of meters times meters times meters. So dividing by 100 3 times would move our decimal point 6 places. 1, 2, 3, 4, 5, 6. We end up with 9.2 meters cubed. In a nutshell, the exponent tells you the number of places the decimal point needs to move, and whether you're multiplying or dividing tells you the direction in which it needs to move. So move the decimal to the right when you are multiplying by a positive exponent or dividing by a negative exponent, and move the decimal to the left when you are multiplying by a negative exponent or dividing by a positive exponent. Let's check comprehension. If you've ever had an existential crisis because of a chemistry exam, click that like button. Thanks for watching Chemistry in a Nutshell.